Good morning. I am Dr. István Szintai. Let me show you the world in my eyes. I think we can agree that the heat on Earth is basically coming from the sun. So without the sun, Earth would be very cold or Earth would be not even exist. So the story must begin with the radiation of the sun. I do not remember this topic from my studies. Law of radiation was new information for my adult mind. As this episode about the basics, it is allowed to get a white paper and a pen. Joseph Stephan was the first scientist who calculated the surface of the temperature of the sun upon measurements, based on his own expression. Stephan's law was made in 1879, a physical law stating that the total radiation from a black body is proportional to the fourth power of its thermodynamic temperature, T. Planck's general radiation law made the opportunity to count the constant number from other numbers. These noble numbers are all the most basic natural constants: 1, pi, speed of light, Boltzmann constant, and Planck constant. The Stefan-Boltzmann law amused me. So compact. The noble numbers say not to argue with them. So this law means that bodies emit electromagnetic radiation spontaneous. This is a basic property of the matter itself. This is the physical phenomenon upon which we can measure temperature without making a contact with the body itself. This emitted electromagnetic performance over unity of surface is proportional to the fourth power of the surface temperature multiplied by a constant number. With this law, we can count how much is the performance of the sun. We can write up the Stefan-Boltzmann law, where the temperature is the surface temperature of the sun. We have to multiply this number with the surface area of a sphere, if we think sun is a perfect sphere. And this quantity is called the luminosity of a star. This energy, this performance, is dispersed over a big sphere around the star, but with the radius of our curiosity, nothing else. So at first it would be the Earth-Sun distance, and if we are curious about this energy over a surface area of a unity, then this will be the total solar irradiance. In the world of the internet, we can look up these values easily. Let's count in astronomical units. After simplification with 4 and pi, we get this expression. If we count in astronomical units, which is the one astronomical unit is the average Earth-Sun distance, so 1 divided by d on square will be 1 as well. So at the average Earth-Sun distance, this equation would look like this if you look up the values from the internet. It's easy. So in the first episode, we could download the Earth-Sun distances. So we can count that that when we are close to the sun and we are far from the sun, we could see how much is the available performance over a square meter. Okay, but how does the internet knows the temperature, surface temperature of the sun? Everyone, and on the internet as well, we know it from this equation, because nobody were there on the surface of the sun and no human instruments were there. How could this be? So basically, the total solar irradiance we can measure, and this is what we can do from the instruments that have been placed in space on board a spacecraft. There are several missions that aimed to measure the total solar irradiance as well. One of these instruments is placed over the International Space Station. This is the total solar irradiance sensor 1, which data you can easily reach to over Lizard, the Laboratory of Atmospheric and Space Physics Solar Irradiance Data, Interactive Solar Irradiance Data Center. And if you choose the TSIS1 daily latest text file, then you can find in the 5th column the values counted to the average Earth-Sun distance. And on the 10th column, you can find the actual total solar irradiance counted to the mass center of Earth. The relation between them you can see on the top right. How these values are, the National Oceanographic and Atmospheric Administration climate data record of daily total solar irradiance looks like this. We have access for scientific measurements and approximations back in time to 1882. So if we can count with these values daily, or we can count with this value of the average, which is 1361 watt per square meter. And as you can see on the plot, this value is fairly stable. There is only 1% increase or decrease in this measured value between mainly in the active period of our star. So in this episode there was no question. We can say that objects emit electromagnetic performance spontaneous related to the fourth power of its surface temperature and related to the size of its surface. And upon this basic physical law, we can have information about temperature of a body without making a contact. And there is more electromagnetic performance available close to the sun than far from the sun. And this says the theoretical approach and says the measurements, and they match. Next time, we will see what happens with a body that is irradiated. Be well, and don't forget the sun will rise tomorrow morning for sure.